Thanks for joining us for Delta RMCs in testing applications. Today's presenter is one of Delta's applications engineers, David McNichol, and we're very pleased that you could join us today. We're glad to have you with us. We'd just like to remind everyone that this session is being recorded and it will be available after the conclusion of the webinar for rewatching at your own convenience. And so with that, I will turn it over to David, and so he can have the maximum amount of time. Thank you.
Yeah, thanks for that introduction, AJ. In today's webinar, we're going to be covering how Delta RMCs fit into the testing applications. We're going to be going through quite a few different command sets, seeing how they work within RMC tools, and we're also going to be able to demo them on a physical system. We're going to cover plots and monitoring tools. This is really a topic that sets the RMCs and RMC tools apart. You'll be able to see this as we go through this webinar. A really great command set, really great tool set to be using. We're going to go through sine wave control, basic cyclic testing. How do you control a sine wave? And also some tips and tricks for changing that sine wave. We're going to be going through adaptive cycle control. This is, again, something that is more unique to a Delta controller. We're going to go through, if you have a tricky system, how do we adapt from cycle to cycle to make sure that you're hitting your targets every single time? We're going to go through our curve tool. Perhaps you don't have something quite so simple as a sine wave, and maybe you have a sawtooth or a square wave, a triangle wave, or something else, maybe something more custom that you'd like to be controlling to. We've got options for that as well. We're going to be looking at XY plots. If you'd like to analyze data, perhaps you're looking at doing a stress versus strain curve. Delta has a really nice solution to the problem there, and we'll be going through that as well. We're also going to be covering using RMC Link for data acquisition. RMC Link is what we use to interface with outside sources. So whether you'd like your data to be captured within LabVIEW, MATLAB, Excel, maybe VBA or VB, we've got you covered in those regards as well, and more topics. So here's a few testing applications that we've been part of in the past. Load testing. We do this all the time. We're going to get to go through and see what force control looks like and how we would present the load testing. Cycle testing, again, this is something where the RMC really excels. I'm going to demonstrate to you guys today how easy it is to program up for a cyclic test, run your number of cycles, capture that data, and bring it to your outside source. Pressure testing, vibration testing, failure analysis, destruction testing, flow testing, and hardness testing. There's really, testing is such a broad market. We've been able to dabble into all of these and really have done a great job in each of these regards. Now, as we go through this, if you have questions, maybe one of these topics is ringing a bell with you, please feel free, use that question box, send us questions. I'll be answering some at the end of the webinar. But in addition to that, we have people who are other application engineers who are standing by ready to answer your questions. We want to make sure that you get what you're looking for out of this webinar and want to make sure that all your questions are being answered. Now, we're going to be going through this webinar fairly quickly. There's going to be a lot of topics here that if you're unfamiliar with RMC tools, it could be a little bit hard to understand exactly what's going on. If you feel that you'd like a refresher or maybe an introduction to RMC tools, we would highly recommend our training video sequence. Like AJ was saying in the beginning, this webinar is going to be recorded and available. So if part of it isn't making sense, no worries. go ahead, watch through this short video sequence. At the end, you can rewatch through the webinar, make sure that you understand each of the concepts that we're going through. And really, this video sequence is a great tool. Again, we're going to be recording these webinars on our website. Right now, we have a current list of scheduled webinars as well as past webinars where you can view these if you'd like to go back and have a refresher. Now, we've got a live example today. I want to talk a little bit about this. We've got a 24-inch cylinder that we're going to be using. It's got a 2-inch bore, 26 gallon per minute valve is mounted on this cylinder, and I've got 1 micrometer feedback coming from an SSI transducer. This system is capable of a fairly quick movement, fast motion, capable of doing around 35 inches per second, and we can hold a position within a thousandth of an inch. So very, very good control from the hydraulic system here. We're able to track motion within a hundredth of an inch as well from this system here. And you'll be able to see as we go through this just how tightly we're able to control our system here. Okay, so let's say you wanted to do some cyclic testing. Perhaps you wanted to run a sine wave, something similar to the sine wave that we have here. Well, we're able to do that within RMC tools. I'm going to say that we'd like to have a sine wave with an amplitude of 1 inch, a frequency of 1 hertz, and perhaps we'd like to run 3 cycles. So something similar to this. This red line here is going to be our actual position. And so this is the line that we're actually going to be caring about. Now, let's see what that would look like in RMC tools. Okay. So I've got RMC tools opened in front of us here. Here's a plot that I ran just before the webinar started. And here is the physical system below. Now, what I'm going to do is trend a plot. I want to explain a few things before I get going here. This light blue line here is going to be my target position. The red line will be my actual position. Pink is going to be my target velocity, blue is my actual velocity, and green is going to be my control output, or the signal that's going to the valve there. So let me run my program here. You can see this system is running below. You can see that the plot is going here. Now, I'm going to be going through a few things in plotting to make the data analysis a little bit easier. If you want to get rid of a few of the items, we simply just click on the colored boxes here just to clean things up a little bit. Like many other applications, I can hold down control and use my mouse wheel to zoom in on a current spot here. So what I'm comparing here now is where is my actual position versus my target position. I'm going to hide my actual for a second. My target is this light blue line, and you can see that my actual is tracking really, really well. It's basically right on top there. It's, you know, within that 100th of an inch the entire time that we are speaking about. So that's our sine wave, right? Let me show you how simple it was to program something up like this. I'm going to open up a user program here. Now, this program only has 2 steps, and it's fairly simple to achieve what we're trying to do here. First, what we have is a move absolute command. And if you're familiar with RMC tools, you've probably seen this command before. This is one of our most often used commands. We're going to be moving to a position of 6. That's where my sine wave is starting. That's my offset of my sine wave. So I'm moving to that position of 6. I'm going at a speed of 5, an acceleration of 25, and a deceleration of 25. Now, I'm sending this to axis 0. That is this physical axis that we can see down here. Once I get into position, this is my link type. This tells me when do I transition from this first command that I sent to my controller to the next command that I'm going to send. And for us, our link type is a wait for. So we're waiting for this condition to be true. And this condition says axis 0, status bits in position. So once we're in position, once we're at that position of 6, we're going to jump down to our next step. Now, our next step is a sine start command. I'm running with an offset of 6. Again, that's my start point, right? Where am I starting? Offset of 6, amplitude of 1, frequency of 1, and 3 cycles. So exactly what we were trying to do earlier, we were given the task, run a sine wave with an amplitude of 1, a frequency of 1, and run 3 cycles of this. This is how we're able to do this. Again, fairly simple program. This only took about a minute to set up here. Really nice and simple to get something going. So now that we've seen this, I want to run this one more time. I'm going to start my trend. Right click on my program, and I'm going to run my program here. And we can see we've got our 3 cycles. We started at 6, and our amplitude is 1. We go up to 7, and we go down in the valley here to 5. So that all looks good. Fairly simple, nothing too crazy there. Now, let's say we wanted to change our sine wave. As we're going through our test here, perhaps we need to change to an amplitude of 1/2 inch rather than 1 inch. Maybe we would like to do a few cycles of one and a few cycles of another. We can do this. Let me show you what this looks like. So we've got our parameter, here's just our basic. Now, if, for instance, we are wanting to run another sine wave here, what I can do is run something like this, where it's still the same, my same frequency, same cycles, everything like it was before, but at the end here, I'm going to be changing my parameter. So I can see here I'm able to run my sine wave, and let's see here. One second here. So I had a delay set up. I set it up for a little bit too long here, guys. This is something that happened earlier. Changing around my amplitude, changing around my frequency. Let's go ahead. I'm going to change my delay to a little bit shorter so that I can actually see this transition here. Let me now download this program, and I'll run this here again so that we can actually see that transition. So there's our transition there. We could also make this, quite a bit longer if we like. I could do something like changing my cycles to 6 here, putting this 2.5 back here as well. And I know I'm jumping around a little bit. I just want to show you guys that we can do this parameter change here. Okay, there we go. Now that's really what I was going for in the beginning. You can see these programs are very configurable. It's nice, it's easy to change things on the fly. If there's something a little goofy in your logic, it's no big deal. So what I did there, I'm going to open up my program again. We're going to see how it looks to actually go through and do this. I've got my offset of 6, my amplitude is 1, my frequency is 1, my cycles is 6. That's what I wanted, right? That's what we had on the plot before. We wanted 6 cycles. I delayed for 2.5 seconds here, and then I'm able to wait until a few of those cycles are done, and I'm able to transition into my next set here. Now, let's say we wanted to do something a little bit different. Maybe we actually wanted to see, well, what's the current cycle count, right? I don't just want to delay, I want to know how many cycles have gone through. And I maybe instead of just waiting for a few seconds to go by, I want to actually wait for a few cycles. Well, we've got a really nice thing we can do here. We've got what we call a sine wave status block. This block allows us to see a few different things. We can see our current cycle count. We can see our current cycle fraction, current cycle angle, current amplitude, frequency, offset, phase. We've got all this information and we can see it in real time. And again, this is something that is very easy to add to our program. So if I jump back into RMC tools, what I can do is for my sine wave, I'm going to set up my status block. Now, I've already got a little block. You can see that I've set up a sine status block here in my variables. So I'm going to select this first one. This basically tells the controller this is where your status block is going to. This is where all that information we just saw earlier is going to. Let me download this here, and I'll show you where it's actually going. I'm going to open up my variable table. And I've got my sine status block here. So current cycle count 6, right? We just went through all of our cycles. Now let me run my program again here. You can see that cycle count goes to 0. We're at 1 now, 2, 3, 4, 5, and 6. So we've gone through all of our cycles. We've been able to see this increment. I could even change my link type. I could say, rather than just waiting for a specific time, I would like to wait for a specific amount of cycles. Really what I'm trying to show you guys here is these programs are very configurable. It's easy to change them, and it's also very easy to see exactly what's going on. So whether you need something to be time-based, cycle-based, maybe even a fraction of a cycle, we've got a nice setup for it there. Okay. So that's a brief overview of how we're doing our sine wave control. But let's say you've got something that is a little bit different. Maybe it's not just a sine wave. Maybe you want a triangle wave, a square wave, a sawtooth. We can do this within RMC tools. It's very easy to grab points, place this within a curve, and we can then run these curves. So it's very easy to configure these, very easy to change these. We can actually even drag and drop points. I'm going to show you this here in just a minute. But these curves, we can follow them. We can say, this is a position that you need to follow, or this is a force that you need to follow, right? Maybe you have a force curve that you want to be following, and that's part of your test. We can do this with either position or with force. So let me jump back to RMC tools. I want to show you what it looks like with a triangle wave. Okay. I'm going to start my plot here. And I'm going to run my curve program here. Okay, so I went to the beginning of my curve. And you can see now on my plot, I'm going through, I'm doing triangle waves here. And you can see it's fairly slow. Again, we can see this happening on the real system here. I'm going to play this one more time for you guys, just so that if you miss the actual system doing this, you'll be able to see it. You can see it's going fairly slow, right? I mean, with a physical system, it's just about impossible to really follow a triangle wave, but we get very, very close, and we're able to control this really, really well. Okay, so let's see what did it take to do this? How do I get something like this actually going within RMC tools? I'm going to open up my program here first. And I can see the first step of my program, again, it's moving to that start of the curve, right? My curve was starting at a position of 1. So that's just how my profile looked. I wanted to start at a position of 1. So that's where I'm doing. I'm moving to this position of 1. I'm going at a speed of 10, acceleration 50, deceleration of 50. Again, I'm going to be waiting until I get to that position there. I'm waiting until I get to the position that I've been looking at. Okay. Now, after this, what I'm going to be doing is I'm starting my curve. My master register is time, and I'm running 1 cycle. This is going to make a lot more sense here in a second, but basically this command we're running is starting a curve. We're running 1 cycle, so that curve that I have programmed in, I'm running 1 cycle of that. Okay, and after I'm done, I stop my controller, motion stops. So let's see what the curve looks like here. So I've got a few curves. I went to my curve section here in RMC Tools, but I've got a few curves here. The one that we just ran was this triangle curve. Now, it's very easy to add more points to this. You can see that I've got it set up here, going from point to point. If I, say, wanted another point, I could do something like this. I could say at 14, we would like to be at a position of 3, and at 16, we would like to be at a position of 1. Just that easy, right? It's very simple to just go through and add more to your curve. Very configurable, very easy to use. Okay, so now I've got this 4 cycle curve here. Well, let's say we wanted to do something slightly different. Maybe we wanted to have this curve, but it doesn't always start at 1. And it doesn't always go back and forth from 3. Maybe we want to do some scaling within this curve. Well, we can do that as well. Perhaps we would like to do a curve where we actually change our cycle time a little bit. Maybe I want to change my cycle time to something like this. I would like to be able to configure it on the fly, and I want to change my frequency from 0.25 hertz to 0.5 hertz. Something like this, again, very accomplishable from RMC Tools. What I can do here is I can, again, go to the beginning of my curve, run a curve start advanced command. This command is really, really neat. We're able to take a standard curve that you have there, and we can basically scale it, right? We can extend the time out, we can run it faster, we can stretch our peaks and valleys. We can do whatever we want here. Let me show you how it's done in RMC Tools. Okay. So my curve start advanced. Again, this is just the exact same thing that we saw on the slideshow. I'm going to be running this command. The big difference here between what we just saw earlier, the regular curve command, is that we've got a master scale of 2. So if you read my label that I've got set up here with my program, it says the curve is started here, but the master time for this example is sped up by a factor of 2. So we basically sped up the time by a factor of 2. We're going through this curve a lot faster than we were before. Okay. Let me make sure this curve is downloaded because I also added that 4th cycle onto it as well. I'm going to run this program here. You can see we're going quicker now, right? We're going faster. You can see that on the physical system. You can see that on the plot here as well. Let me run that one more time, just in case you missed the physical system. Okay, so you can see these curves are very much so configurable, fairly easy to use. We can do something like a triangle wave here, but maybe your application isn't quite so simple as just a triangle wave, a square wave, or a sawtooth. Perhaps you're gathering data from an outside source. Maybe you're gathering acceleration data from a vehicle that you're driving down the road, and you want to then be able to play that data back. We can do that with our curves as well. So something like that might look a little bit more like our custom curve that we have here, right? Maybe this is some real world data that you've taken and you then want to play back through the RMC. You want to be able to do actual real world testing. Well, we can do that as well. What I'm going to do is change my program here. I'm going to say instead of a curve ID of 1, that was our triangle wave, I'd like to change this to that custom curve ID, right? And that custom curve, I can see my curve ID was a 4. So changing between these curves, again, fairly easy and simple. I'm just going to change that ID that I had set up from a 1 to a 4. So I'm going to go to my curve start. I'm going to change this to a 4. I'll download this here. I'm going to go back to my plots, start trending, and I'm going to run my curve start command. Now, we could see this is running one cycle of that real world data that I've collected. And it was very easy to jump from one curve to the next, right? It was not something that took a ton of time. Very, very easy to do. Okay. So curves, great tool, very configurable, really flexible. It's going to be able to do what you're wanting it to do with your system. But let's say you have other problems. Maybe your system is just difficult to control because you're trying to go at a very a high amplitude, a high frequency. Maybe we're just not quite able to get what we're wanting to with our standard PID tuning. Perhaps a standard PID is just too slow for what we're wanting to do. Well, we've got an awesome tool that we call adaptive cycle control or adaptive amplitude control. This adaptive program is able to change our amplitude, our phase, our offset, all on the fly, and it's a very, very flexible program. So the plot that I have here, the red you can see is my actual position. The blue is my target offset. The green is my peak target, and the black is my valley target. So with standard PID, we were not able to achieve this, right? It's just too slow. Maybe this frequency is just far too fast for a standard PID to keep up with. We're able to use our adaptive cycle control to actually adapt. So you can see each of these cycles is getting closer and closer to where the targets actually are. And at the end here, we're hitting it dead on, right? After just a few cycles, we're hitting our target valley, we're hitting our target peak, and we're right on our target offset. Now, let me show you what this actually looks like from our system here. Now, for the purposes of this exercise, I've just detuned our system a little bit. I don't really have any load that I'm pushing on. You can see that my cylinder is just free floating. So to really show you guys what this looks like here, I'm going to be detuning it, and I'm going to show you what it looks like with this set of gains when we've got a non-adaptive program and we're trying to run our sine wave here. Let me just stop this trend. I'm going to trend it again. This will rescale it and make it a little bit easier for everybody to see. But I can see just like I was looking at on the PowerPoint here, I've got my peak target, I've got my valley target, and then I've got my my offset here in the middle. Now I'm not hitting. I'm close to my offset, but I'm not hitting my peak, and I'm not hitting my valley. And you can see that my cylinder, it's physically moving back and forth right now. So let's see what it looks like if we are to run our adaptive program here. You can see it starts out, right? We're still not hitting at the beginning, but you can see over just a few cycles, we're able to get right dead on exactly where we wanted to be. Okay, so just like we were seeing in our Excel or our PowerPoint rather, we're able to build up over time, and over time we're able to hit this peak, we're able to hit this valley, and we're able to be right on with our offset. So we're actually able to do this with a fairly small amount of tuning. This has been such a great program to have as a thing in our back pockets. If you're really trying to do something with very high frequency or higher amplitude, and for one reason or another your system just can't keep up, a lot of times we can solve this with our adaptive amplitude. We're able to make sure that each cycle is right on, and we're able to do this for as many cycles as you like. Now, how is this accomplished, right? How do we do this? Well, it's actually fairly easy. We've got a nice user program set up where we're able to adjust very easily from our variables here. This is basically all the setup that you need to do to achieve something like I just did there. You're going to set your offset, right? Where is the center of your sine wave? You're going to set your requested amplitude. You're going to set the requested frequency. And these are your three main parameters. Now we can adjust our gains a little bit, just how quickly are you going to be adapting? We have a default value of 1. Generally, that's okay. Sometimes you need to do a little bit of adjustment rather, but generally, this is going to be okay for most applications. So really what you're needing to do here is just tell the controller what's your offset, what's your amplitude that you like, and the frequency that you'd like. Now, I can see in RMC tools that I have my offset set up for 5. My requested amplitude is 0.4, and my frequency is 3 Hertz. And again, I just have that standard gain for amplitude and for offset. So really, this is all I needed to do for my setup here. I can change this. I could say I would like it to be 0.5 maybe for the amplitude. And we can run this again. You get to see here, it's very easy to configure. You can see that my my requested amplitude has gone up, my offset has stayed the same, and again, the system's able to keep up with it really well. We're able to track very, very well here. Everything is looking like it should. So just that easy. The program, it's a little bit more complicated, but we've done all the programming inside it. You can configure it, but even easier than that, if say you like how this looks, but perhaps you need an adaptive program for force control or a triangle wave. Well, no worries there. We've got you covered. This is going to work for position sine waves, position trapezoid waves, position sawtooth. It's adaptive mid-cycle. And it's also going to run fine for force control. So we've got many, many examples. If you'd like to see one of these, maybe this is exactly what you need for your application, please, again, use that question box, reach out to us. We would be more than happy to answer anything that you need, and want to make sure that you've got the resources that you need as well. Okay, so that's how we do our adaptive control. We've been using the plots pretty frequently here. Hopefully you've been able to see that it's a very nice tool for data acquisition, but perhaps your application is a little bit different. Maybe you don't just want a standard time-based plot. Maybe you want something more like the example that we've got here, where it's an XY plot. I've got force on my y-axis here, and my x-axis is position. So kind of similar to showing stress versus strain on this curve. Again, this is something that's very easy to do. We can do it within RMC tools, so you get this nice, all the benefits of using the tools here. We're able to capture these really great looking plots, and we can do a lot of different things to actually analyze these as well. Okay, so what I'm going to do here, I'm going to go ahead, go into my my program here. What I'm going to be running is this force program. I want to talk a little bit about force control, and we'll then see how this is going to be used with our XY plots. So what I'm going to do at the beginning of this program is I'm again going to be using a move absolute command. We use this command all the time. Again, it's a very useful command, something that you're going to be using a lot in RMC tools. But I know that I'm going to contact force at around 21 inches. So I'm sending my position to somewhere past where I know that I'm going to be seeing that force. I'm going to be going to a position of 22 at a speed of 10, acceleration 50, deceleration 50. Now, when I get to a position of 20, again, that's going to be before I actually make contact with the rubber stopper here at the end of my cylinder stroke. It's an inch or so right before it. As I start to approach that part, what I'm going to do is I'm going to reduce down from a speed of 10 to a speed of 5. This is going to make that transition to force a whole lot easier. So I'm going to transition to a speed of 5, and I'm going to wait until I see a little bit of force. When I see a little bit of force, I know I'm ready to go into force control. So I'm going to be waiting until I see 500 pounds. That lets me know you've made contact with your part that you're pressing on. You're ready to go into force control from there. Okay. Now, once I've seen that 500 pounds, what I'm going to do is use one of our enter pressure force control commands. So I'm going to go from a position control that we've been seeing throughout this webinar to a force control. Now, this force control here, we're going to be ramping to 3,500 pounds. I'm going to be ramping there with a nice smooth S curve, and I would like this ramp to take 1 second to get there. Okay. Now, once I get there, once I'm at force, right, I'm waiting until I'm at force. I'm waiting until I'm at 3,500 pounds. Once I'm at force, I'm going to go down to my next step. Again, this is going to be a ramp force, time-based ramp force, and we're going to be ramping with a nice smooth S curve to 1,000 pounds, and we're going to take 1 second to get there. Once we get there, we're gonna wait until we've hit that 1,000 pounds. But once we've made it there, we're going to use this conditional jump link type, and we're going to jump to the beginning of our force loop here. So I've made a little label on the top of this step here, and I'm just going to be going back and forth the whole time here. So I'm basically going to be doing cyclic force testing with this, right? I'm going to be compressing and decompressing back and forth, and I'll do this until I tell it to stop. What I really want to emphasize here, guys, is something like this, where there actually are quite a few steps, is fairly simple. It's easy to understand, right? We just have these 4 steps. It's easy to program. Even if you're new to RMC tools, something like this, it's not going to take you much time to program. Very nice, very easy to understand what actually is going on. And it's, again, very, very configurable. If I decide, hey, I don't need to go from 3,500 to 1,000, I'd like to go to 1,500. Very easy to see what's going on. You can see that I've got comments on each of my steps here, letting whoever's using it, whether it's the person who programmed the system up to begin with or someone new, it's very easy to understand what is actually going on in this system. Okay, let me jump to RMC tools. I'm going to show you first what this looks like just with a standard plot here. I'm going to run my XY force program. You can see I'm going, and now I'm transitioning back and forth with my force here. But let's say I wanted to see something a little bit different. Maybe I wanted to see the XY plot of this, right? Let me show you guys that. I'm going to move back to a, we'll say a position of 10. I'm going to say speed of 10, 50, and 50. I'm just going to retract this here. I wanted to show you guys a few things though before we do this. First off, I wanted to show you with the force control here. I can see that I'm going. Once I cross that threshold, that 500 pounds, I then go into force control. Right here is where I'm going into force control. This is my section here. Okay, so we're in force control there. I'm going to retract. I'd like to show you guys what this looks like with our XY plots here as well. So I'm trending an XY plot. This just looks really goofy right now, but let me run my force control program. So we can actually see this XY plot going now. Again, this bottom axis right here is my position, and this top axis, or the y-axis rather, is my force. So x-axis is my position, and y-axis is my force. Now you can see I'm compressing little rubber plates here, and so we can actually see the drift here, right? We can see what is actually going on between these two. You can see that the material it's slowly getting compressed, and now it's pretty much reached an equilibrium, right? The position isn't really changing much from where it was. We're not really actually compressing it down and squeezing it down anymore, but you're able to see something like this on a physical part when you've got these XY plots set up here like we do. Let me pause this, and I want to show you a few other things that we can do with our XY plot. Okay, I stopped my trend here. Let's say I wanted to see the difference between these 2 points. Well, I've got one cursor here. I can say drag it to my point here, and I can see that my actual force here is 2,477, right? If I wanted to see, well, what was the force at while I was retracting with the same position there? Well, I can show my second XY cursor. I can bring it to the same spot here. And with our tool, let me make this a little bit easier to see everything. We've just got a lot of information here. So let me expand my window. Now, with this tool, I'm able to see, well, what is cursor 1? Cursor 1 is at 2,450 pounds roughly. Cursor 2 is at 1,580 pounds roughly. So we can easily see the difference between these two cursors. We can actually even see what's the difference. That's all been calculated here, so I can see my difference is 800 pounds. There's a lot of information that we can gather from these XY plots here. The other really neat thing that we've got with XY plots is we've actually got a time-based cursor selector as well. It may be a little bit hard to see on your screen, but I've got a little box here that shows me where was the force at a particular time. So as I move this time, I can see what my time is here, 36 seconds after I began my plot here, and I can track it through here really easily. You can see what is the time seconds here at the top as I'm dragging my cursor, and you can see this little white box traveling along, showing you what point it actually is at that point in time. So again, just a very nice tool for analysis. And that's really what I'm trying to get across here, guys. You've seen a lot. I know it's a lot of information. very quickly. What I'm trying to show you is that we've got features for just about everything within side testing. We've really tried to make sure that everything is user-friendly, it's easy to use, and yes, there are a lot of options here, but again, we're more than willing to help you through whatever you need. If you'd like us to reach out and contact you, maybe you have an application that you're needing some help with, let us know. We're more than willing to help you out through whatever you're doing. Okay, that's a nice brief view on XY plots. So we've gone through a lot of RMC tools, how they're used, and we've been able to see the plotting as well. Just being able to see how are our plotting tools used. Very awesome tools, but at some point, you're going to want to take the data and you're going to want to bring it from the RMC to whatever application you're using. Well, again, we've got a really nice tool set for doing that. Data acquisition can be achieved with VBA, VB, LabVIEW, MATLAB, Python, PHP, C#, C++, and many more. Many Windows-based languages can use RMC Link. DMCP, Delta Motion Control Protocol, can be used for C or Linux or other applications as well. But for just about any application you're wanting to grab data from the RMC, we've got tools available for you to do so. MATLAB, we've got a stellar example for MATLAB. It's very easy to use. It works right out of the box. Nice pre-canned examples. You can send commands with this example, right? The same way that we've been sending, say, the move absolute command or the curve start command. We can do that just the same with something like MATLAB. We also have a really nice example where we're capturing plots. I was able to capture this plot just by using MATLAB here. Just takes a few minutes if you've already got MATLAB installed in your computer. Go ahead, browse to RMC Link. Again, if you've got RMC tools downloaded, you'll have RMC Link as well. Just browse to it on your desktop. You'll be able to see that we've got the MATLAB examples included inside there. Pop one open and you'll be able to grab plots in just a minute or two. It's a really nice example. We've got something very similar. If you'd like to use VBA, perhaps you're wanting to capture data using Excel. Again, very nice, very configurable, pre-canned example, very easy to just click read and save plots. We're able to read these plots here. You can see that there's a plot that has been populated here. Again, very configurable, easy to use, and works right off the get-go. We also have really nice examples for MATLAB. This is one that's we've put a lot of time into making something that looks really good. Very easy to connect up to a controller. This one is actually going to be connected to an RMC70 that's online here. So if you're a LabVIEW user, you can open this up. You don't even need to have a physical RMC on your desk. You can connect to ours remotely. You can send commands to go back and forth. You can capture plots. Very easy to use, ready to go. I actually would like to demo this for you guys here, just so you can get an idea of how nice this is here. Okay, let me bring this over. All right, so here is our example here. Right now, I'm connected to an RMC70 at deltamotion.com. Again, you could even do this if you have MATLAB already on your PC. You can download our example today, and you can get this going. You could even get it going as I was doing it. Right now, I can see that I'm at a position of 9. I can move this to a position of 1, move it back to a position of 9. I can even trend a plot here. So it's very neat. I can say I'd like to move to 1 now. back to 9, and I can see this happening in real time on my RMC. I'm grabbing all this data here very, very easily. So really, really nice tool. Again, great for data acquisition. We've got a lot more description within RMC Link itself. Just a stellar tool for grabbing that data out. And really what I want to get across here, guys, with all these examples is that we have many, many examples. We've done communications with just about anything you can think of for data acquisition, and we've done it very successfully. We're able to help you through the process and get things running. So taking the data out of the RMC and putting it into your application is not going to be an issue. Okay. As a summary, we've really covered a lot in this hour, guys. I know that this is a ton of information. Again, like we said in the beginning, this webinar is going to be available to view at a later point. If you felt a little bit lost in one of the sections that we were going through, feel free to look through those training videos. It'll give you a little bit of a more background on RMC tools and probably make things a little bit more understandable if you hadn't seen RMC tools before this. In summary, Delta has the right tools for the job. We've got many, many tools for the testing industry. Want to make sure that all of you guys are supported, that you have what you need, and we want to walk with you through the process. Plotting and monitoring, something that is very, very close to Delta. We really want to make sure that we're always getting the data when you need it. We want to make sure that we're able to see everything that's going on. And we also really emphasize being able to take that data and bring it to an outside source. Sine wave control. You saw in the beginning, we have really nice sine wave control. It's very configurable, easy to use. Adaptive amplitude. If you have something that's a little bit more tricky maybe to control, that adaptive cycle control is what we can do. Whether it's offset that you need to adjust, amplitude, or phase, we have that covered. Custom curves, again, we're able to follow these custom profiles. We're able to do it very well. RMC Link for data acquisition, just like I showed you, we've got many examples for each of the whatever you'd really like to do. We've got great examples for it, and we're more than willing to help walk you through them, and many more things. Okay, so what's next? If you have an application that you're ready to use an RMC for, we've got many good options. Really, the big difference between our offerings here, the RMC 75, the RMC 150, and the RMC 200, is the axis count. The RMC tools program that I was using as we went through this webinar, that is going to be used with each the 200, 150, and 75. So we were using an RMC 200, but we could have just as easily been using an RMC 75 or an RMC 150 for this demonstration, and nothing would have looked different. Delta resources, we've got very knowledgeable Delta sales, technical support team, and distributors. Great team of people here at Delta, and we work with amazing distributors. Really want to build your guys' confidence. This is something that we've done over and over again in our over 30 years of experience. We have very knowledgeable technical sales team, technical support. We've got a great team of application engineers that are just waiting to take your call, answer your email. There's a good chance that you'll be talking to me if you call into Delta or one of our other awesome application engineers. And we work with amazing distributors, very knowledgeable, whether it be in hydraulics or the Delta controller, very knowledgeable distributors. We've got a nice set of application docs, application specific examples, and a hydraulic design guide. We're going to go into here just a little bit more. AJ will tell you a little bit more, but we've got a great guide that's going to be able to take you through how we would recommend designing a hydraulic system. One other thing that I'd like to mention here is our advanced training option. If maybe this webinar was information that you had already known. Maybe it was just a brief refresher, but you'd like to go much deeper. We would highly recommend our advanced training. That's going to be in person here at Delta, and it's a 3-day course. We really get to dive in. You guys get to go hands-on. The system that I'm using here for this presentation, you'll actually get to control that and many others. It's a very useful next step if you want to go deeper into the RMC applications here. Okay. What we're going to do now, I'm going to go ahead and I will hand this off to AJ. And yeah, just want to thank you guys again for attending this webinar. Feel free to ask questions, reach out. We would love to get in contact and help you out with whatever you're doing.
Thanks, David. We had a couple of questions. Maybe you'd like to address those just live. I didn't know exactly, but we have 3 valves on that demo system. And I think you were using the Bosch Rexroth valve for the purposes of this webinar. Is that correct?
Right, that's correct, yes.
Okay, very good. We have a question says, I would like to see an example of an adaptive force sine wave, if possible.
Yeah, we have an example. I don't know if it would take a little bit of time to set it up here. So what we can do is perhaps if you're interested in the adaptive force example, let us know, if there's anybody else who would like to see it as well. We could set something up maybe for a live demo, and we can definitely send you over that project and example and be happy to walk you through it. But it works very similar to how you saw the position there. It's just where we've got force parameters rather than the position parameters that we're seeing there. But it's very similar.
Very good. And we had a number of questions asking if the adaptive amplitude example is available for download. And the answer is yes. We have a downloads section on the Delta website. That's at deltamotion.com. And if you navigate to the download section, you can find the adaptive amplitude examples. But also in our forums at forum.deltamotion.com, if you search for adaptive amplitude, there are links there. That may be the easiest way actually to find the examples, is to actually go to the forums, because there are links there to examples that you can download for RMC tools for the adaptive amplitude control that David was presenting today. David mentioned our hydraulic design guide. Peter Nachtwey, president of Delta Computer Systems, these are a collection of articles that Peter has written. You can get this design guide for free, and these are recommendations for how to design a hydraulic system optimally for good control. And so if you would like that, you can visit us at deltamotion.com. You'll see this down about halfway or at the bottom third of the page. You'll see this free design guide. Just click that. You'll have an opportunity to put in your mailing address there, and somebody from Delta will get in contact with you to verify, and then we'll mail that out to you. The recordings of this webinar will be available at deltamotion.com. You'll see a webinar link there where you can go to the schedule of upcoming webinars and then links to recordings of past webinars. We're also posting them in the forum at forum.deltamotion.com. And then finally, on youtube.com, if you search for our channel, Delta Motion Control, all one word, you will find recordings of our past webinars there as well. Again, thank you for your time this morning. We hope that you can join us on future webinars, and thanks again.